Hello. Okay, so first topic that we're going to be going over, I'm sure everyone's pretty familiar, HTTP. So first step in any CTF or in web security in general is information disclosure. So the website up there is the main website you can look at for steps on how to find information on the website that you're looking at. So web servers, what they do is they accidentally often expose information that they don't intend to expose to the public. And the best place to start checking for this exposed information can be in the comments, in the source code, robots.txt, sitemap.xml, or even using Git dumper. You can also use Burp Suite to look at the response headers to see what software stack is being used by the web application. Request tampering is another step in web security. So anything that you send through your browser can actually be intercepted and modified before it reaches the server. And like I mentioned before, the main tool that you use is Burp Suite. So the three main points that I wanted to make was the proxy is what sits between your browser and the server, and it lets you capture every single request. So if you have a look on Burp Suite, when you send through requests and you go back to HTTP history, you can have a look at what requests you've sent through and what responses you've received. And then interceptor lets you intercept a request before it reaches the server. You can edit the request and then forward the tampered request. And similarly, repeater lets you resend a modified request as many times as you want. So you can test different parameters and different values. So just general rule of thumb, a well-built server should never only trust client-side information, and it should verify the information on the server side. So in terms of tampering with HTTP requests, every time you interact on a web application, your browser constructs the HTTP request itself, but you can change this request and manually create one. So the two main HTTP methods in web security are GET and POST. So GET retrieves a resource, and the parameters are going to be in the URL when you retrieve this resource. So when you open a website and you can see that it has the parameters in the URL. Whereas for POST, when you submit data to the server, the parameters are going to be in the request body. So for POST, it's mostly used for login forms or any sort of similar form that requires you to submit something to the server to update the server's data. And that's just the standard form structure for a HTTP request. So to summarize, when you're looking at any CTF challenge, you should be considering what request is being sent to the server, what parameters are in the request that's being sent to the server, and what's going to happen if you change those requests. And then the last thing you should consider is the server validating input on the server side, or is it trusting what your browser is sending through? Any questions? Okay. Okay, so Callum, do you want to do GWTs?
Yeah. Okay, thanks everyone. God, this is a small room, I'm realizing. So yeah, hopefully this, oh wait, is that the new one? Yeah, hopefully that's working now. Can we all just take like 1 or 2 minutes to, oh wait, give it a second. Okay, there you go. Yeah, hopefully everyone can scan that. It's a bit annoying. You have to like log in first, maybe, if it doesn't let you in straight away. Otherwise, just go to the rubric website and you should be able to sign in that way. What? Oh, okay. Can you send a message? Can you DM Mahir about the salesman, please? Okay. Don't worry about that then. Cool. So JWTs, typically when a server is lazy and they want to store all that information on the client side, they use JWTs, as I'm sure you're familiar with. Um, Also, I should say, like, all of these slides will be available later if anyone's interested. Yeah, so JWTs will store user data in a hash, oh, sorry, and then they will also hash it securely, which makes it impossible for us users to modify that data. Obviously, sometimes they mess this up, and the main ways we exploit that is by either trying to crack the signing token they used for the JWTs, as you might have seen in some of your CTF challenges. The other way we can get around this restriction is by trying other exploits that sometimes work on JWTs. So a common JWT exploit is the non-algorithm exploit. All this does is tries to change the algorithm a JWT uses to sign to be no algorithm at all. And if you can get away with that, you don't have to have a signed JWT. So a command like this, using the awesome JWT tool, will allow you to mess around with a JWT to try and bypass all of the security things on it. Yeah. Any questions on JWTs? I might try a quick demo. It'll be pretty fast, guys. So let me just get Burp Suite up. Actually, I'll come back to this because I think we'll get through the other topics first, maybe. Okay. Fast tokens are just like JWTs. They also sign the contents within them, so we can't, change our values so easily. Similar to JWT tool, we can use Flask unsigned to try and brute force the signing keys. Yep. So just like this command here, which is going to try and crack the signing key given a JWT, we can try the same thing with Flask unsign, which you can also search up and try and download yourself. If you want to differentiate quickly between these two types of tokens, take a look at the second kind of full stop there in the token. And you can see after this dot here, the Flask token will always have like some sort of short value, whereas the JWT will always start with EYJ. So that's a quick way to kind of identify what you're working with, which is going to help a lot, I think. So yeah, any questions on that? Cool. If you want to try a quick challenge that has to do with JWTs, I'd recommend going to the CTF page, and I believe it's called Token Gift. Just for practice, if you're interested. Okay. So the other thing we should cover real quick is idle. If you ever find a endpoint that kind of directly accesses some sort of information, I believe it was the support challenges in the CTFs, if I'm not mistaken, that did this. So yeah, if you ever see someone accessing like user by their ID or by their username, or some sort of information like this, try and go through all of these routes. It's sometimes worth writing a script to do this as fast as possible for you. You can always check, like, does user 300 exist? If user 300 exists, it's going to be faster to write a script to check this for us, right? Yep. Cool. So SQL injection. Do you want to talk about SQL injection? Yeah, and then, yeah, Annika will finish up with SQL injection, and then I'll come back to do XSS and stuff.
Okay, SQL injection. So, SQL is how web applications communicate with their databases. So the most common query that SQL uses is select, which retrieves data. So there's an example one just there. So select from users where the username is Annika and then the password is 1234. So that means the browser is sending a request to the database to search for a match where the username matches and the password matches. So the query is built by the server and it's inputted into the query string directly. But because it's inputted directly, the server has no way to distinguish between input that's actually data and input that's actually SQL syntax. And that's where SQL injection comes in. So if we input this payload, the first one up there, instead of a username, the query becomes what I have up there. So inputting that will result in the database returning the whole table of users, and the login will also succeed, instead of what it should actually return, which is an error. You can refer to payloads, all the things. Specifically, the SQLI folder has a lot of good payloads for you to test out. And then the other one is union injection. So Boolean injection, it's a bit different from union injection. So union injection actually allows you to extract the data from the database, including tables not targeted by the original query. So what union injection does, it appends a second select statement to the original query by the server. So it's taking that original query and it's adding on union select username password from users. And then an issue that happens because of this is that the original select statement and then the second new select statement, they both have to have the same number of columns. And if they don't match, the database will throw an error. So how would you approach this? The three main steps to union injections is you should try and start by finding the number of columns. So I've just listed some sample payloads that you can start with. So you can do union select 1, 2, 3, and just keep enumerating until you can successfully see how many columns there are. Once you know the number of columns, you can try and query information schema.tables to list all the tables in the database. So that's sample payload as well. And then once you have the list of all the tables in that database, you can now try and see what columns those tables have. And that's when you can try and extract specific information from those tables. So the payload on the right there, that's a combination of everything from steps 1 to 3. And inputting that would allow you to extract the username and password from the users table. Yeah. So next one is SSTI, which is server-side template injections. So when a web application wants to display dynamic content instead of having something hard-coded, such as personalized message, it will use a template. So the template is a HTML file with placeholders. So if you are, for example, you create an account on a certain website, the account might say, "Hi, Annika," so that they most likely use a template for that to update your name. The template engine will take this and it'll replace the placeholders with real values, and then it'll send the completed HTML to the browser. We have a vulnerability created here when the user input entered is inside the delimiters instead of being passed in as a value. So what I mean by that is instead of where it has the double brackets username, instead of that just being passed in as a value, you're actually changing you're actually changing username. So that results in the user being able to write data for the server to execute. Yeah. So the two payloads up there, they're pretty simple payloads. The first one, it's a very common test to check if you are dealing with an SSTI CTF. So for the first one, if it returns a 49, that means it is vulnerable. And then the second one, it's called a polyglot. Yeah. So that one, it's to account for all types of server-side template injections, because there's a lot of different types of engines. So the second payload will try to account for every single type of template engine that exists. Yeah, so you want to try and identify the engine being used from error messages or context clues. Payloads, all the things is, again, a great reference. You can also follow the diagram to try and figure out which template engine is being used.
All right. I will once again ask for your help here, guys. I promise this time it will be working. Hopefully that's working this time. It should be the same link as before. So if you already have it up, it should be fine. Is that working for everyone? Yes. Thank you. You can do that. Yeah, guys, please do not select 10 tickets per person. That would really ruin our financials. Um, yeah, exactly. Yeah. Cool. I think everyone's mostly done with that now. Uh, so next up we have command injection. So as you're familiar, command injection is simply when a web application uses user input in their command, which is kind of dumb, like unsanitized user input. So if we ever suspect this is happening, typically you can take a good guess that this is happening because the web application is doing some sort of like interaction with the operating system. This might look like unzipping files or listing out the contents of a directory. If we suspect that they're running commands, we should try these payloads that try and run more commands, right? So this is my favorite one, dollar, and then 2 brackets, and then cat the file you want to cat, for example, or run the commands you want to run. This simply just spawns a new shell which runs that for you. However, most of the time, these challenges aren't that easy, right? We're typically met with a filter. Sorry, this is a bit of a full page, but yeah, typically we're met with a filter when doing these command injection challenges. So I have a couple of tricks here to just try and get around these basic filters. The most common one is sort of that they block spaces and nothing else. And of course, spaces are like imperative when we're running commands because it's how we have arguments, right? So if you want to use spaces in your commands, try the IFS variable here. So you can like use this by just having a dollar and then 2 squiggly braces and IFS in the middle. IFS, or this sort of thing here, usually evaluates to a space and then a tab and then a new line. So it kind of just acts as a space in our case, right? And we can use it to separate any sort of list of arguments if we need to. Sometimes you have a problem with this because IFS is like multiple characters. This is pretty much just going to get the first character over here with a 0 and 1 saying get me from index 0 to index 1. So that's just like an array indexing thing in Bash here. So that's just like an easy way to get around spaces being blocked. Obviously, you can also try base64 for encoding your payloads and stuff. If they block specific characters, so especially when we're working with file paths, as most of you are familiar, we can replace them with wildcards. And in Bash, a wildcard just looks like a question mark, right? So the most common example here is like, let's say they blocked an F when we wanted to run the command get flag. We can replace that F with a question mark, and Bash simply goes, okay, I'm going to take a look at all the files that have a any character that matches this sort of structure. And they look for any character in the question mark position. And of course, /getFlag would match that description, right? And you can go kind of crazy with this as well. There's also a lot of other ways we can get around this on Hacktricks. Some nice ones, for example, is just instead of a semicolon, if you want a semicolon, use a new line. That always gets around there. Or you can use like a or, which is just like in C when we use 2 or things to kind of have 2 statements next to each other in an if statement. We can also use backticks. I'm not sure if you can see that, but that's like kind of on the top left of your keyboard. And it will do the same thing. as this over here. It'll spawn a subshell for you. So yeah, those are some like nice tricks for you. Any questions on command injection? Anything? Cool. Okay, now we get to XSS. XSS is definitely like the juiciest part of this course, I think. Anyone agree? Yeah. So I'll try and work through this a little bit, and I've also made some challenges to help out with this. But yeah, this is the basic description of XSS. It's simply when we can use a script on a web page, right? And typically our goal is just to fetch our own domain and attach a cookie. If we can do this, then of course we'll have access to the person who has run this script's cookie. And typically that's like the flag, right? So that's usually our goal to get to that point. However, the 6443 admins hate our lives and they don't make this easy. So they're gonna try and filter this out. And our goal is still to just get around all of their stupid filters. Typically, this will include something like just adding another script in here, and they'll strip out this first script. As I'm sure you've seen this in the lectures. They strip out this first script, which leaves the second script here. There's also this lovely website on Portswigger. Some of you, I'm sure, have seen this. It has like 800 different ways to run JavaScript. All of these will run JavaScript for you. So like, if you're in an exam and you don't know how to get around their filter, come here and use like this weird thing that makes no sense because they wouldn't have thought of that, right? That's not always gonna work, obviously, but it's a good try. Yeah, sometimes we are only able to identify into the attribute of a HTML tag. So like commonly, maybe we can inject into the name attribute of an image. So make sure to remember that we can also trigger XSS through like on error. So we can always escape these attribute tags and write something like, you know, image name equals X. On error equals our payload, right? I'm sure everyone's seen this, hopefully, by now. So that should be good. But yeah, just like for a typical flow of how I like to approach these basic XSS challenges. So this is obviously excluding CSPs, excluding cores, and all of that stuff. But typically, I like to start by just checking, do we have bold tags that work? Because if we do, it's super easy to just, you know, then test for script and image tags. If script and image tags do work, we can always just try fetching to our webhook and stealing the cookie. If we can't use script or image tags, we can look for filters in the source code that we can break. Otherwise, we can try and figure out if there's some sort of filter that's online maybe. Or sorry, filter on the back end that we can reverse engineer and also break. If both of these things fail, that's time to start looking at Portswigger typically. Otherwise, if the bold tag never worked in the first place and we still want to try XSS, then we look for our attribute injection. That's typically how I like to approach these challenges, although don't stick to my script because it's not going to work for everyone, obviously. But yeah, it should be a good little start maybe. So yeah, maybe let's take a look at an XSS challenge now. So if anyone wants to work along with this, it'll be in the bad search part here. It kind of combines SQL injection and XSS, so we should get some good practice with both of those. But let's take a look over here. Okay, so we have like a support ticket website, and again, if anyone wants to try this, it's at bad-search.secso.cc. The reason we might see this and go, oh, I want to use XSS on this website, or actually, can anyone tell me why they think this might be an XSS challenge right off the bat? Yeah, exactly. That's exactly right. Yeah. So like when there's some stuff that says, oh, let's go to admin search. Oh, okay. I mean, maybe I have to actually search for something first. Yeah. But if I do a search here, it tells me I can send this search to an admin. which is a very typical thing in XSS, or at least in CTF challenges. It's kind of unrealistic that you have this, but if we have some way to communicate with an admin and get them to visit a web page, which let's take a look here. They say if we send it to the admin, they will open that search. So that might mean if we can send an XSS payload to an admin, we might be able to steal their cookie, right? And get their secret, for example. However, the problem here, if I try this, first off, my actual input isn't reflected. So if I do this, I can see my A actually comes up nowhere. So even if I could write script, it wouldn't work. But I'm going to come here and just try it anyway. So let's try script alert 1. Okay, and you can see it blocks this thing anyway. Typically here, we want to try and enumerate what the actual firewall does. So for example, does it try and figure out if we're typing in script, right? No, we can actually, oh, I think this might be annoying. Okay, it looks like it does actually block on script. I forgot that. But yeah, you can also see here, it blocks on the open brackets, or sorry, open tag, close tag. Does it block an alert? Oh, it doesn't block an alert. So what about fetch, actually? Doesn't block on fetch. So we should be able to do most of our payload. It's just that we need to get around the filters for both this and this, right? And you might think like, obviously to get around script, actually, does anyone know any good ways to get around script being blocked? Is there any other ways we can trigger XSS without the script string? Yeah. Anyone want to take a guess? Yep. Yeah. So if you remember, I can use image on error like before, right? And we can see none of this. Oh, okay. I guess on error is blocked maybe. Is on error blocked? Yeah, on error is blocked. But like, again, this is where we can go to Portswigger and be like, what is it called? Portswigger cheat sheet. Here. Let's go here and look for other ways to trigger XSS. So maybe I have image. And they have all this on error stuff here. I don't really care about on error. Maybe there's some other ones here. Yeah, so there's like SVG onload alert 1, which we can expect would do a very similar thing. So maybe I can come here and see, do they block SVG onload? No, right? So I can always use this other payload that's mentioned in Portswigger to try and trigger my XSS, right? And they even say we don't have to use greater than here. So that gets rid of this character that we had to worry about. So then our problem here is that we just can't open this tag, right? Does anyone have any other ideas about what I should try at this point? If I can't write in an open tag, like that's a pretty big deal when it comes to XSS. I can try URL encoding it, yeah. So URL encoding just is a way to, sure, do whatever. It's just a way to kind of give websites special data as a hex code. So I can try this. And that looks really good, but like it's not getting blocked. But also, again, this doesn't get reflected anywhere on the web page, right? Which is a bit of an issue because I actually need my script to come up here. But if I take a look at like the source code of this, nowhere do I see %3c. Oh, I guess I do. I'm lying. But it's in the input box, right? This isn't really that important because it's not going to get rendered as a script tag. I sort of want it to come up on the raw HTML. And again, I could try something like maybe escaping that script tag there. Let's see if this escapes it. So yeah, I can do that, but it doesn't matter because here they HTML encode it, right? This means quotation mark in HTML language. So that's all safe. I can't really get around that restriction. Any other guesses as to how I can try this? Yeah, actually I will try putting it in here directly. Yeah, so that still gets blocked. Okay, this challenge is a little bit dumb. What if there's another vulnerability on this website that would allow me to get around this restriction? What other vulnerabilities do we commonly see with like search filters or search boxes? Yeah, SQL injection, nice. So like a simple way to try it for SQL injection is just chuck in the quote there to see if they're doing anything weird. And it gives me the search query failed, which again, like we didn't get that before. So yeah, I mean, I'll try like this to show you. So here I put in a quote and the search query fails. This probably means that there's some error that's happening when I add a quote into the search box, which likely tells me that this is a SQL injection thing here, right? So I can come here and try SQL injection. Um, Anyone have good ideas for how I should approach this SQL injection? Maybe? Or 1 equals 1? Um, so if this works, it should just return everything in the database, right? So let's try that. And you can see, oh, no, come back. Okay. Yeah, you can see here, I tried this and it actually worked. Like I've managed to return everything. So I have SQL injection here, right? However, there's no like valuable things here. So let's maybe continue with the admin functionality and try and actually get uh, XSS. So does anyone have any other ideas for how I can get XSS using this? Yep. Yeah, that's really smart. So like, yeah, if I could add to the database through my SQL injection, then I could just take my XSS from the database and search for it. Unfortunately, like I've kind of made this in a way where if you try and do multiple queries, like you try and do stacked queries or something, maybe to add to the database, it will fail. But there's another way to get our own information uh, from a query, right? Mhm. Yep. No, that's exactly right. Yeah. So if I do a union statement, it's going to try and search in my union statement as well. So we can come here and maybe say, let's union select just one. Maybe I'll do it as a string because it gets angry if I don't. So this fails, which means there's probably more fields in the union. So we try 2. Ah, that still fails. Let's try 3. Oh my God. Let's try 3. And there we go. Like you can see here, I've put in union select 1, 2, 3, and I've managed to get my input reflected here with 1, 2, 3. And there might be some sort of like statement running here because I noticed the %, which is typically used in like statements. Does that make sense for everyone with their union injection? We're kind of just adding this as an entry in the database. So now we can try adding our like XSS here, right? If we imagine this input might just be reflected directly onto the page without a filter. So let's maybe start changing 2, or maybe I'll make 3 there. Really? Yeah, maybe we can make 3 the payload here. So let's come here and go this script alert 1 /script. Actually, let's not try script. Let's try the SVG on load equals alert1 and see what happens there. Yep, blocked by text filter. So maybe I can't use the left thing here as well, right? Which makes sense because it's the same input field. Um, does anyone have any idea how I can use the SQL injection now to get around this restriction? It's kind of advanced. This is a bit like of an advanced one. So yep, that's exactly right. So in SQL, like maybe I'm thinking now, SQL, how do I concatenate text? Uh, text. Yes. Google AI, help me. So, yeah, you can see I have this like concat function. Maybe this is useful. Let's try this. So if I come here and I go, instead of just having this as a string, um, we're going to have that and something else. So we can go concat. Maybe let's just do an A here, and let's have the rest of the string be here. And then because this is in like a like statement, I need to close off this concat function here. So everything looks normal. And then maybe just to make it work, I'll have all1 equals 1, just so the string, when this gets put into the actual query, the comma or the apostrophe they use will go there. That should work. Oh, that failed. Why did that fail? Okay, maybe there's another way to concatenate things. Sorry? Yeah, I am. So I just want to see if this works right now. Um, oh, ChatGPT save me. I can use okay. I can use this thing here to also concatenate. So maybe let's try this. Okay, so I'll come here and then here. I can go that. Let's take this back to what it was before. Yeah, so I can concatenate text here, right? Um, again, this is just like Googling and like, what if this works, right? So now the next thing I need to do is how can I make this a value be a left or a less than sign? Does anyone know what I have to do here? Or can anyone take any guesses? Um, there's a function that we use in Python, right? Has anyone ever seen this? It's like CHR. CHR just converts a number to a character in back, right? Or sorry, just it converts a number to a character. So we can see like maybe there's a way to convert ASCII to text in SQL. Um, let's see. Um, this guy uses char. I actually don't know if that works. I think the way does CHR work? Okay. Um, okay, let's try char. These guys are saying char works. So maybe I can come here and go something like char 65, which is the code for A. Yeah, and that seems to convert like the number 65 to the letter A. Right, cool. Let's just search up real quick then. ASCII code for this. Um, yeah, ChatGPT. 60. Thank you. Okay. Let's try 60. And something weird happened, right? Um, what happened here? Uh, SVG onload equals alert1. Maybe if we just add like a semicolon. Just like that. Maybe we'll just concatenate this with a closing bracket. So 62. Yeah, cool. Um, so that's kind of like an example of a way that we can get around these weird filters. In this case, it was a bit complex because we had to obviously look at SQL injection. Um, but like feel free to try and find other ways to get around this filter. Um, yeah, typically it will require maybe a little bit of like out of the box thinking, right? Just to show this off properly, I'll also get the flag. So to get the flag, we usually make a webhook. I like webhook.site, although there are better options. And let's just grab our URL here. So let's make our payload be, we're going to fetch our webhook.site. It probably needs to be in double quotes. So we have our webhook.site link there, and then we're just going to have grab document.cookie there. And that should work, I believe. So let's try that. And we can see we get a request on webhook.site with the cookie there. Maybe I'll just increase the size of that a bit. Cool. So let's come over here and just send that to the admin. And then I will tell you the admin is gonna find that and it will work. But I won't give you the cookie. You have to do it yourself. Cool. So nice. Any questions on that challenge? Or on XSS or SQL injection or anything? Yeah, no, okay, cool. So the next thing we'll quickly cover is the CSP. As I'm sure you know, it stands for Content Security Policy. And it just tells the browser what content on the page to actually process. We can read the CSP through the headers, and it typically looks like this. So we have Content Security Policy, and then we'll have some sort of field. So in this case, script source, and then it will say self for where the content should actually come from. Self just means our own domain in this case. If you're unsure on how a specific CSP works, we can always go to the MDN docs. So let's say we wanted to know script source. It's pretty nice to go to script source, MDN. Yep. And this should roughly tell you what the script source does and what each value does here somewhere. What was it? Self. Yeah, something like that. It should be someone. Okay. There is another great website for this, which is CSPevaluator.com or CSP-evaluator.withgoogle.com. And we can always come in here and just paste a CSP. You can just copy this directly from some headers. So let's try, what was it? Script source, none. Let's check this. And we can see here, it evaluates our CSP and it'll give us warnings on what is dangerous about the specific CSP. And this is really useful as a way just to quickly identify what the vulnerability might be. As I'm sure some of you know, like this doesn't always work. It'll work sometimes, but it's a good starting way to just figure out what might be the vulnerability here. So cool. We'll look at some typical ways to bypass CSPs. The main two ways, or the most common two ways, is looking for somewhere on the website where we can get arbitrary JavaScript execution. So if we can load from a JSON-P file, JSON-P files allow us to specify a function, or sorry, a callback to run, which the JSONP file will process and run as its own JS. So if you ever find a JSONP file anywhere on the web page, make sure to check out that because it's a pretty good way to get around CSPs. If a CSP allows a content delivery network, so you can't really see it there, but it says ajax.googleapis.com. I'm sure you've seen this in the challenges perhaps. We can usually use this to like import a vulnerable JavaScript library, and we can use that JavaScript library to get XSS without actually ever running a script directly. Yeah, cool. Let's take a look at a CSP challenge real quick. So, I see people are flagging this now. Okay. Where was it? I think it was delivery service. Okay. So let's take a look at this. Again, the way we know this might be an XSS challenge is because we can find a admin review here. So if we can talk to an admin bot and it checks previews for some reason, and we can give it a URL to just access, like that's a pretty good indicator that there's an XSS vulnerability on this website. Because why else would they add a bot that would visit websites in the challenge? Anyway, that's a bit meta, but let's go and see if there's an actual XSS vulnerability here. We can come here, maybe try script, alert 1, script, same thing here. And if we preview this, we see the recipient field is fine, but in the driver's note, we get like an error here. We see maybe some sort of script happened because there's nothing here, but we never actually had any code execute. And because it's a CSP, if I open the inspect element, there it is, it will show that it's violating the content security policy, which maybe you can't see because it's really tiny. Yeah. So it's telling us that this website violates the CSP because we're not following this. And again, let's chuck this CSP that we've gotten into CSP evaluator to just see if there's anything straight up that we have an issue with. Yep. And here it says, yeah, you have script source, but cdn.jsdeliver.net is known to host JSONP endpoints and Angular libraries, which allow us to bypass this CSP. So that's a pretty good hint as to how to attack the CSP here. And we can go over here and just search up what JSDeliver is. So it's a CDN here. That's pretty cool. Let's see if there's any CSP bypasses on here. Maybe someone's already documented one. Oh, wow. There's a package on this website called CSP bypass. That's pretty cool, right? Yeah. So like, this is just one example of a CSP that's vulnerable, but hopefully it shows you how to take a look for where you might find the vulnerabilities in the website using Evaluator. So let's take a look here and see how to use CSP bypass. It shows us an example with unpackaged.com, but let's just try and copy something similar over. So we're going to first import the script. So where is this? Okay, so we're going to go here and change the vulnerable field to be, really? Let's change the vulnerable field to be importing this vulnerable NPM package that's available here. And then this should be fine because it's a script tag that's just importing some other script, and that's allowed by our CSP. We can come over here and then see how to exploit it. And it looks like we just use this CSP equals alert one thing. So Let's just copy what they tell us to do. And we get our alert there. And then we can always try the same fetch webhook URL thing to then get our cookie stolen. Cool. Any questions about CSP? Or do people want more examples or anything? He just called me.
He just called you. What can he look at?
Okay, cool. Let's get back to it. Let's take a look at cause. Okay, so cause is maybe one of the more complex things in this whole course. It's a way for different subdomains to communicate with each other, typically by sharing cookies in a very safe way. This can be abused by us to steal sensitive data from a main domain, given that there's an XSS vulnerability on the domain that's trusted by the main domain. So let's take a look at how this usually happens. So here we have the trusted domain, which is actually vulnerable to XSS. So we have some sort of payload that we can put in this main domain, which is going to make a request to the actual main site, see, from the vulnerable site. And this request is going to send over the token or the cookie to the main domain. And because the main domain actually trusts this child, I probably might have messed up something here, so tell me if I'm incorrect. But this main domain, which has the /secret endpoint, trusts the child and goes, okay, I'll use your cookie and access the secret. And then using our fetch request, we can receive this secret in the vulnerable subdomain and send this back to ourselves, right? So yeah, that's how cause works. Yeah. Any questions on that? Cool. Yep. So typically we should try looking for XSS. If there's another user, most likely some sort of admin that you'll find, there's some sort of like talk to admin endpoint that we can interact with. So we should always try XSS then. You might want to be sure to make sure to also look out for things like header splitting if you suspect cookies are HTTP only, which is sometimes a big problem. So always make sure to check if HTTP only cookies run early. And always try and start with simple payloads. So try and start with like just a break or a bold tag. If you can get a bold tag, it's very likely you can get XSS some way. Or if you can't get XSS, you can always try to do our other attacks. Like, I guess that's not really if you get a bold tag. But if there is an admin bot, you can always make sure to try things like clickjacking and CSRF. Although it's less likely you'll find those in the exam. Yeah. Any questions before we get pizza? Or does anyone want me to cover other stuff in the course? Oh, sorry. Hi. On prompt injection? Are you talking about in the final or? I don't know anything about the final. I'm not really affiliated with the course. Yeah. I would say, if I was to guess, I would say it's unlikely because like it might break, but I don't know. Don't take that from me. I have no idea. Yeah. Anyone else have questions? Cool. If people want to try, we have a lot of good challenges here on the CTF website. Oh, not that one. Yuck. On ctf.secso.cc, we have a ton of challenges, and by a ton I mean 10. So please try out all of these. I swear they're really good, most of them. And yeah, we can come around and help you out if you have any questions specifically. Yeah. Does anyone want me to try another challenge or something? No. Okay. No one has any other topics they'd like covered again or in more depth? Cool. Pizza is coming very soon if you want to stay. And also would really appreciate it if some of you could take the time to fill out our feedback form. It's really short. It'll take like a minute, 30 seconds max to fill it out. And it would really help us make these better in the future. Yeah, feel free to stick around and try all the challenges we have. Try and get number 1 on our leaderboard. Thank you, everyone.